Hello, it's Knox, and today we're going to do another demo, diving a little deeper into the new feature for Carbon Black Cloud, the malware scanning feature. And today we're going to look at how we can stop a pipeline when Carbon Black Cloud detects some malware, or when it finds, or even rules that deal with vulnerabilities that may cross a threshold. We may say that we don't want any critical or high vulnerabilities going into our environment. And so we can set up our CVCTL tool to run a function called validate. And that validate function is going to reference some policies that we have set up. And if our image, when it scans the image, if it violates those policies, the pipeline will fail. And a report will go to the Carbon Black Cloud, and there'll be a link and some log information here at in the failed pipeline. And this is great because we want the pipeline to fail if there is malware, or if there is a vulnerability threshold that we have defined that gets crossed. So we're going to walk through how to set that up. It's going to require us to set up our CVCTL tool correctly, get some API keys and define a build step. And then we're going to have to define a scope. The scope will also have the same build step in it. That's how we're able to tie the two things together. Then we're going to create a hardening policy, and then we will add the rules that we want inside our hardening policy. Sounds a little complicated, but it's not that bad. We're going to walk through it nice and slow and get there. So let's go ahead and jump over into the Carbon Black console, and let's start with number one. Let's get this CLI created. Let's get some API keys, and let's define a default build step. So to find this, we're going to go to inventory, and then we're going to click on Kubernetes, and then we're going to click on clusters. And once we get here, there's a tab right here called CLI config. So we're going to click on that guy. Now, when I first started working with the Carbon Black Cloud, I wondered why I had to add a CLI. That didn't make sense. I thought, why don't I just download the tool? Well, the reason is we're going to add the CLI, and we're going to generate this API key. That's what's important, because when we use the tool, we have to pass in our API keys to the tool so that it is able to link us back to our instance of the Carbon Black Cloud. Now, I've already created this guy, this Knox GitLab dev pipeline test, we'll call it that. So because I've already created it and I need a different name here. Test. There we go. And then we'll do the same thing for a description. Now, when you're creating this, I like a descriptive name, and I just am using the same name as my CLI name as my default build step, because it's just going to be really easy to remember that way. This default build step, remember, is actually very important, because the default build step is going to, that's going to be what connects your validate command back to your hardening policy, because it's here in the scope. In the scope, we define that same build step name. So that's what's going to tie these together. So make sure you remember it, and it's the name you want. So we hit next. We're going to generate an API key. Again, we can call it anything we want, but I'm just going to rename it the same thing, Knox GitLab Dev Pipeline Test. We're going to generate. Now, when I hit next this time, it's going to give us this command that it says we can copy into our terminal. Now, this command is very important because not so much for the command itself, but because of what it contains. It has the API ID, the API key, the org key, the SAS URL, and notice right there it has our default build step, Knox GitLab Dev Pipeline Test. So all the information we need to pass over into, in my case, GitLab, because I'm running GitLab, it's all right here. So you would want to copy this, and you would want to put it somewhere safe, at least long enough for you to be able to come over and put it in. So I'll show you over here. Inside my group, I have an automation group, and my microK8's demo is inside this automation group, and I am defining these variables. So here I have taken the contents of over here, this file that it was given to me, the API key and the API ID, and I have stored them in variables here in GitLab, and they are now accessible to my repository. And when I run my pipeline, these variables will be automatically injected into the environment. And that's great because I don't have to worry about them being seen. They won't be exposed in the logs. They're kept secret that way. And so also because I'm storing them up at a group level, if you were running this in a more production environment, a team could choose to have engineers or developers who only have access to this repository and don't have access to the group level. They would still inherit all of those variables, but would not have the ability to change them. And so that's another way to be able to keep some separation and to keep these secrets secret. So we're going to hit cancel here because we already have a CLI API set up with this Nox GitLab dev pipeline. All right, so now let's go back. So we've got step one done. We're on our way. We're doing great. So we've added the CLI. Now we need to add this scope. So let's go over here to scope. Oh, it's in the same place, by the way. Inventory, Kubernetes. It's right under clusters, scopes. Okay. So inside scopes, again, you'll see I already have created a scope. And if you were going to create a new scope, you would hit add scope over here. Now, in this case, we're not going to worry about that. I'm going to go over here to options because I've selected my Nox GitLab dev pipeline. And I can edit the scope, and this gives you virtually the same window that you would see if you clicked on add scope. So you're going to choose your name. If you did click on add scope, there's going to be a few more possible targets, but in this case, you would want to click on the build phase because this is a build phase target scope that we're creating. You would want to click on the specific namespaces and or build steps. Remember, we've talked a lot about this build step thing, very important. And then we're going to check the box for resources in specific build steps. And there it is. We have selected the Nox GitLab dev pipeline build step. So there's that build step again. It's very important. It keeps popping up everywhere. So now we've defined a scope and we have a scope that includes our build step. So remember, the scope, we're going to look up here again. The build step in the CLI allows the CLI to, when it runs the command and when it runs scans, send the API and the build step information to Carbon Black. Carbon Black is going to use that build step to tie it to a policy. It's going to say, hey, do you have a policy that has this build step in it? And it's going to, and Carbon Black Cloud is going to say, why, yes, I do. I have a hardening policy with these rules with that build step. And so when the scan is done, it will apply these rules, and then that information will be able to go back. So that's how these things are all tied together. So now we're on to our third and fourth step. They're going to happen quickly together here. So now we're on to the hardening policies. So you're going to want to go up to enforce. And when you go to enforce, you are going to want to go to K8's policies. And then once you get into K8's policies, you're going to want to click on this hardening policies. And I have already created it. You can just click add policy. It's going to ask you to add a scope to it. And we've already done that, so I'm not going to worry about it. I'm going to hit cancel. Yes, and I'm going to instead go into here and see here, it's the exact same window. It's going to edit the policy that I already made. So Nox GitLab dev pipeline, we select the scope. So this is, remember, we're editing the hardening policy. We are attaching it to the scope, Nox GitLab dev pipeline. That's what we're doing right now. And then we go to next. And now we are adding rules. So it's really nice. These rules are already here for us. we could do the deny ephemeral containers, and these are different things that were not what we're doing right now. But these container images, we want a couple of these. So fail critical vulnerability and known malware. I've added both of those already. So if I take them both off so that we can see them get put back on here. So here we go, fail on critical vulnerability. You can set it to alert and add it, and you can see there it says alert. Or in our case, we're going to go ahead and hit fail on critical vulnerability. We're going to hit block, and we're going to add that rule. And so now the rule has been added with the block action. And then we have known malware, prevents deployment images with known malware, and we're going to block, and we're going to add that one as well. And now we are going to hit next again. And we have another screen here for reviewing validations, and then we confirm the policy, and that is it. We have done it. We have created a policy with this scope that has the build step defined in it. And so now we're going to go back over to our code, and we're ready to do this. So I'm going to go ahead and run this now, because it's going to take a second to run. You can see here I have my commit message, hardening policy test Python extra. Python extra is the trigger I'm using to kick off this job. I'm going to push my code. So you can see here, get just pushed my code. So while the pipeline is getting started up and the scan's starting, let's go ahead and look at my job here and how I changed it from last time. So here's the Python extra job. As I said, the trigger here on the commit message is Python extra. We have an exception for my Harbor. We're going to log into Harbor. We're going to build our image from our Docker file. We're going to download cbctl because I still haven't baked it into this image yet. And I was running the cbctl command with all of these environmental variables in the command line. And I accidentally, while I was preparing for this demo, removed them and ran the command without the variables, and it worked. And at first, I didn't understand how did it work without my variables. And I realized that the cbctl command is smart. And if these environmental variables exist in your environment, it will find them. So when you run the command, it will look for the required environmental variables, and as long as they exist, you don't have to add them on the command line. Very nice. The other thing I realized about the validate command, which is the command we have right here, image validate, is that if I'm running validate, I don't need to run the scan and the validate. That just kind of is redundant, because validate will scan the image, and then when that scan is complete, it will take this build step. Remember, here's that build step that we've been talking about the whole time. And so there it is. I define that build step, Nox GitLab dev pipeline, and I've told it to validate. And so it's going to use, it's going to pass that build step in along with all the other API information. It understands it's a validate command. And so that means I want it to reach out to the cloud, and I want it to grab my hardening policy and check it. And then that also tells it that I want it to fail. If the policies have been violated, then that pipeline needs to fail. So let's go over here now, and we're going to check on our pipeline, little rocket guy here, and we'll click on the pipelines. And we're going to, oh, our pipeline failed. But guess what? That's what we wanted it to do. So let's look and see why exactly it failed. So if we scroll all the way to the top, we will see that our image ran. We pulled it, and we created our image. Here it is. We created the image. There it is, Docker harbornox.rocks GitLab Python extra. So the image was created. We grabbed the cbctl tool, and then we ran the image validate command. And so it scans the image. Notice it scanned it, fetched it, read it, collected it, analyzed it, and look at what happens. It found known malware, and it also had vulnerabilities. It had both, so it failed on both accounts, both of the rules that we put in. And now if we go ahead and click on this link, which I love that that link is right there in the log, and I can click on it. And there we go. And we see here, here is the container image scan results for harbor.nox.rocks, GitLab Python Extra 1.1. And we see here that it had violations. That's why it failed, because it found known malware. And so, and we can see all the other vulnerabilities it found in the scan. We see the file reputation, and everything has worked as expected. So again, really exciting feature here. We are able to cause our pipeline to fail, and to fail in a good way. We want the pipeline to fail. Our job failed, and that's what we wanted, because we don't want these images to push forward into our harbor and make our harbor dirty. So I hope you've enjoyed this demo, and have a great day.